So the purpose of today, explaining those key concepts around the theory, best practice of testing, how to test with modern Salesforce development methods, like testing features and scratch logs, etc. And really, it's laying the foundation for what's needed to embed a sort of automated regression capability into continuous integration builds with Salesforce using, second generation packaging. I'm not going to get into that today. We're not going to talk about continuous integration. We're not going to talk about, version control and source repositories and Git, etc. That would be nice to follow this up with a presentation like that. But today we're just going to talk about DX and how to use that tool to facilitate testing, really. So the primary audience today is really anybody that works with Salesforce that's interested in quality. But the main focus is going to be on quality assurance engineers. So if you are a developer, please still listen. I think it's interesting for you as well. But the primary focus today is on QA engineers. You don't necessarily need any experience in automation, but we will be getting our hands dirty. We're going to be writing code. We're going to be executing code. And so if you come from a functional testing background where you've been traditionally doing manual tests, following steps like in an Excel spreadsheet and point and click manually, I think it'll still be interesting to you. And if you're one of those, if you have a role like that and you're interested in getting into automation, I think this will also be interesting for you. Of course, you need a basic understanding of Salesforce, and then just a final point on this. We're not going to be covering UI testing today. So things like testing Lightning, UI responsiveness, we're not going to be doing that. So the kind of testing we're doing today is business logic testing. So creating data, having a feature, a trigger or process builder, something like that in Salesforce, and testing that when data undergoes certain events that we are getting expected outcomes and expected results, okay? So the tools we're going to use today are Salesforce DX, and I'll explain what it is in a second. We're going to need a developer org, we're going to need a Scratch org, a little bit of Excel, and a little bit of basic Apex, okay? I have specifically designed this presentation to not get into Visual Studio. I know Salesforce DX works very well as an extension to Visual Studio, but what it does is it actually hides what's really going on with Salesforce DX. And I want you guys, especially if you're getting exposed to DX for the first time, to understand at a command line level. Sorry guys, if you're not talking, do you mind just going on mute? Really to understand at a command line level what DX is doing each step of the way. And having that grounding and understanding is going to take you further. And once you've got that grounding, sure, then go use Visual Studio with these extensions and stuff. But I see a lot of people that they start using IDEs, they plug in DX, they don't really understand what it's doing in the background. And the same with Git. If you're ever using Git, learn it on the command line first before you start using source tree and these kind of visual tools, so you really, at a deep level, understand what's going on. We're not going to be looking at continuous integration today, so no Git, Bamboo, Jenkins, Jira, Selenium, Profile, all of these tools that are very commonly in the back pocket of an automation engineer we're not looking at today. I'll talk later about where those will fit in to what we're doing today, but that's not going to be the focus. Okay, so what is Salesforce DX? SFDX stands for Salesforce Developer Experience Command Line Interface. So the CLI stands for Command Line Interface, okay? It's a tool which makes life easier and more pleasant for not only developers, but it can also be used for testers, okay? It can be integrated with development environments and be used more as a GUI than a CLI, but today we're going to be using it as a CLI. The main use cases for developers are to manage Scratch orgs, and we'll talk about what a Scratch org is next, to move metadata between Scratch orgs and local repositories, and it works very well with Git to manage version tracking, okay? It's also used to package code for deployment to sandbox production using second generation packaging, okay? So this new world that Salesforce is moving to with second generation packaging, DX is for a developer is really your tool that you're going to be using to facilitate that. When it comes to testing though, DX can also be used to import and export large volumes of data from your repo into a scratch org, for example, and out again. It can also be used to execute anonymous Apex regression scripts that live in your repo and evolve over time, right? So the key thing is here, as a QA engineer, you can take control over that process. Your regression scripts don't have to live on the Salesforce server. They can live in your repo in a little folder that only you worry about, right? And we'll get into that later. And then finally, it's useful to automate testing business logic, which is what we're gonna cover today. So what is a scratch org? The key difference between a scratch org and a sandbox is that scratch orgs are designed to be disposed, right? They are designed for short-term use, and they don't carry any configuration over from production. So if you provision a scratch org, it's like going to Salesforce and buying a new Salesforce license. Yeah, you're going to get a vanilla org with no configuration changes in it, even if the dev hub that scratch org is associated with has lots of configuration on its production linked Salesforce server. Okay, you're always going to get a brand new org. And so what that means is that anytime you provision a scratch org, the source of truth for all of your metadata is not actually Salesforce itself, but your repository. So the process for a sandbox is just to go into your production org, provision a new sandbox, and you will have all of your production configuration in that sandbox. The process for a scratch org is to create one first in DX, push your metadata changes from your repo into that scratch org, and now you're at the level where your scratch org is looking like production. It's also designed for developers and testers, and so you don't get all the user licenses carried over from your dev hub or your production org. I think you get 2 Salesforce licenses, and so you've got to be careful really around how you use scratch orgs for testing, because there is a limit on how many licenses that are there. The lifetime of a scratch org is a maximum of 30 days, whereas a sandbox is indefinite. There is no concept of refreshing a scratch org. The data in a scratch org is your data. And most of what we're going to talk about today is actually about that. It's about having control over the data that gets put into, manipulated, and exported from a scratch org. It's also very quick to provision a scratch org. We're going to do it live today. It takes about a minute or 2. And as discussed earlier, the source of truth for a scratch org is always your repo. It's never your production Salesforce org. From a testing perspective, and this is where Salesforce is now moving into, and it's sort of catching up with the rest of the software development world, is that scratch orgs are designed to sort of facilitate feature development and feature testing and sort of scenario testing within those features. They're not designed to cover full sort of end-to-end processes and end-to-end regression cycles. They are designed to be spun up, have a developer develop something specific there, and then a QA tester log into that scratch org, test it, or in fact spin up their own test scratch org, ask the developer to push the metadata into that scratch org with their changes from their branch, and then test it there. Whereas sandboxes are now fitting into that sort of traditional SIT, UAT connected space where you've got your integration sitting there and you can actually follow through full end-to-end regression scenarios. When it comes to testing, pretty important, we need to understand this, right? So specifically from a Salesforce perspective, what the difference between a unit test is and a functional test. And there's lots of different names for functional tests, but from a Salesforce perspective, a unit test is something that is the responsibility of a developer, right? It is not the responsibility of a QA to write unit tests. A developer writes a piece of code or a feature, and they need to then write a unit test to cover the functionality that they're done. And the format for that is just more Apex code. You write Apex code to cover your Apex code. The purpose of a unit test is to automatically test a discrete unit of work from the perspective of a developer normally. They're technical in nature. The scope of the testing is quite narrow, and I don't want to say are there to primarily cover code, because they shouldn't be, but from a Salesforce perspective, that is what Salesforce enforces, is that your unit tests are actually covering code and not necessarily actual scenarios or use cases, or from a business perspective, what the business is expecting that feature to achieve, okay? And they can prevent regression, but at a much more narrow level than a fully ended functional test would do. They are a mandatory requirement at Salesforce. You absolutely cannot publish Apex code into a production environment without having its code covered by unit test. And the drawbacks really are that, no offense to any developers on the call, but most of the time, unit tests cover happy path. Okay, if you have a really good developer, they'll be covering negative, making sure there's no false positives in their test cases. But when you're under pressure and you're coming to the end of your sprint and you've got to pump out features, happy path is what you're going to be testing, because that's what's covering your code. Okay, and so what that means is that most of the time a unit test is just covering positive test cases. They're not looking at the full spectrum of what really needs to be tested. Okay. On the functional test side, from a Salesforce perspective, these are not enforced. Mature organizations will have mature QA teams that will make sure absolutely that there are functional tests in place to prevent regression. And those come in two flavors. They can be manual or they can be automated. If they're manual, typically you'll find these as steps in an Excel spreadsheet or something like that links back to Jira. I think there's some other plugins for Jira that can tie back to your issues and user stories and help you script from a manual perspective what is needed to do. And if they're automated, they'll normally be something like Selenium or Provar or some other WebDriver thing that plugs into to a browser to automate mouse clicks and so on. In a scripted language, and they're there to test end-to-end business logic, and they're written from the perspective of a user. They are not technical in nature; they are business-oriented in nature. Okay, the scope of testing is wide angle, and they must comply with the acceptance criteria in a user story, and they prevent regression more robustly. Now, because they're optional and very often manual and labor-intensive, the usage of regression tests and the maturity of regression test suites very much depends upon the discipline of a QA team and the resource that a business has to spend on that QA team. Okay, and so while regression tests, from at least from my perspective, if done well, provide a better protection against regression than unit tests do, because they're optional, that you don't always find them there, and so they can't be relied on for releases. I want to skip over quickly into just simplify this. Okay, so talking about DX and what DX does. So from a sort of feature perspective, there's three main areas where DX can help a developer and or a tester. Okay, the primary thing that DX does is it moves metadata around between orgs, between your local physical machine and Salesforce Scratch orgs and sandboxes in production. Okay, and the way it does that is you've got some commands. So for Scratch orgs, you've got the source push and pull commands, right? And these kind of work in the same way that Git works, right? When you do a push or pull command, DX will monitor what has changed, either locally on your machine, or if you're doing a pull from Salesforce, it'll monitor what's changed, and it will pull that metadata changes into your local repository and vice versa, okay? And this is fantastic. So from a developer perspective, that really speeds up the process of getting metadata from your machine onto the Salesforce server, okay? It is much faster than trying to build a package, trying to figure out what needs to go in that package, building a manifest, deploying it, etc. Okay. When you're working with source code, your metadata in a repository, you're not sitting in Dev Console writing code, right? You're using an IDE, and you're working with files on your computer, and you're committing those to a Git repository, right? And so you still need a way of getting that work onto your Scratch org to test it from a developer perspective, right? And so these commands here are fantastic for that. Not really something, though, that would be useful to a tester. When it comes to sandboxes, and indeed production as well, Salesforce DX can do both first-generation packaging and second-generation packaging. And also, which is fantastic, I've never tested this myself, but there are commands there to convert your packages. So if you have a first-generation package, you can actually convert that to second-generation and vice versa. And you have all of these commands that are very much akin to the old Ant, Apache Ant with the Force.com IDE plugin way of deploying and retrieving metadata from Salesforce using the metadata API. So all of these commands here use the classic Salesforce metadata API. With second generation, you've got these commands to create packages. You also have commands for creating first generation packages, but from a second generation packaging perspective, you have a way of taking your metadata and creating a package and then installing that on a remote server. That's not going to be the focus today, so I just wanted to go quickly through that. So that's the first key area. The second key area is data, moving data in and out of Scratchworks, right? When you provision a sandbox, you have the option of, if you're lucky enough to have a full copy sandbox, bringing everything over, all of your data and your metadata over from production. When you're working with a Scratchwork, you don't have that luxury, right? And so DX gives you these commands to help you get data in and out of your orgs. I'm not going to go into detail now because we're going to run out of time, but if you're working with a single object, you can use the Salesforce bulk API using these commands like upsert, and then to extract data from your org, you can use a socket query. And later we'll look at this, which is really fantastic from a tester's perspective, is that you have a way now of storing data which is nested, right? So if you imagine you're a tester, you've got 100 accounts, and those accounts are all different. They come from different lines of business, and they've got different cases as child objects and different contacts, different opportunity records, all covering different sorts of scenarios, right? You're now able to keep all of that data in your repo as JSON objects, right? All nested and packaged up. And every time you provision a new Scratchwork, it's one command, brings all of that data into Salesforce. You can then manipulate it. You can export it out again using these commands. And we'll look at that later. Really, really cool. And then finally, there's test automation. And there's a bit of debate around whether DX should be used actually to automate tests. I think, why not? If a company doesn't have the budget for tools like Provar or Selenium, why not use Salesforce to not only execute unit tests, which will always be there, but also to execute QA automation engineer built functional Apex regression scripts. So to run unit tests, you've got these commands, but the distinction is unit tests always live on the server. They always get executed on the Salesforce server, right? Whereas if you're a QA automation engineer, you can build your own anonymous Apex code that you can run from your repo using DX on a target Salesforce org without ever needing to kind of open that org up and go to dev console and run a test or all that kind of stuff. You can do that. You can build your own suite of scripts that live in your Git repository with your JSON files to facilitate your testing. And all of that can be packaged up, bundled up, and brought into your continuous integration pipelines and automated. And the key commands there are Apex execute. And the key takeaways here is that those scripts will typically run from your repo. They will never exist on your Salesforce org. Okay, so back to our presentation. I won't go through all of these, but these are some of the, from those category perspectives, these are the more common commands that you would use. We'll go through some of them today. Most of them apply to both Scratchworks and sandboxes as well, with the exception of push and pull. And there's a very specific reason for that, right? So this isn't just the DX product team deciding not to allow you to push and pull metadata from a sandbox. There's a reason for that, right? So the theory is that you should always, when a developer is happy that they've done their piece of work and the QA has tested that on the Scratchwork, and from a functional or feature perspective, the testing is done, that needs to be then merged into a release branch, right? And that is then when you will actually package up those changes and deploy them using a proper package to your sandbox, right? So actually deploying to the sandbox is part of your testing actually, because you're going to have to deploy to production as well. And so getting metadata into a sandbox you need to use a package. You need to package up your changes and then deploy them using the package. So from a QA perspective, what's going to be more relevant to you is the data features and the test automation features. I think the metadata is typically something that developers will stick to. Okay, so what are the sort of typical pitfalls that people fall into when testing? There's a couple of categories, but the main one I want to cover today is scenarios. So those kind of things that differ between environments, right? So data volumes can differ, right? You may test something on a sandbox or a scratch org, and with 100 accounts works fine. Oh, now we move into pre-prod and we've got 10,000 accounts and it doesn't work anymore. You get all sorts of supple limit issues. Okay, so data volumes can differ. Data access can differ. Data samples can be unrepresentative, right? The data that you test in your scratch org doesn't represent actually reality in production, or your data is just plain wrong. It's formatted incorrectly, etc. Environments can be different. Permissions can differ between users. Licenses can differ. Metadata can differ. You can have locale and time zone setting. All of these things, Salesforce DX can help you with. Okay, from a data perspective, you control that process, right? Remember, unit tests create their own data, and they dispose of that data at the end of the execution cycle of a unit test. Functional tests use real data, right? And therefore, with Salesforce DX, you have a way of storing that real data as JSON fixtures or CSV files or whatever in your repo, and methods to deploy that data in volume using scripts into a scratch org. And so you can test the more likely scenario that things look like in production in a scratch org. Similarly with environments, right? You may test something on a sandbox that doesn't have a feature activated that's in production, right? With a scratch org, you can provision a scratch org with whatever license you want. Live chat, person accounts activated, whatever you want, you can define that, right? Whether you've got that license or not in production, you can define that in your definition document, in your scratch document, and I'll look at that later, so that your environment that gets provisioned has all of the goodies that you need to do a proper test. And then finally, interpretation, right? So these are more sort of technical things, data environment. Interpretation, it always comes down to how well defined are your acceptance criteria in your Jira user stories, right? How waffly are they? How vague are they? How concrete are they? Are they black and white? Are the scenarios all well thought out? And that's what I want to take you guys through now quickly. So the last bit of theory for today is this, okay. So quick joke, right? Built the staircase exactly as design boss. Yeah, it looks about right, okay. This is a typical case where a tester, I don't necessarily mean a QA tester, but maybe a UAT tester has tested something from one perspective, right? And then as soon as that thing goes into production, people actually start walking up the stairs and they can't get upstairs because not all angles have been taken into consideration. So if we take an example, right? As a sales user, I want the account shipping address to match the billing address for new accounts so that I don't waste time with data entry. Okay? So the acceptance criteria for that are, given a new account creation screen, when I enter a non-null billing city and I click save, then the shipping city should match the billing city. Okay? And another acceptance criteria could be, when I change the billing city to a different non-null value, click save, and the shipping city is already defined, then don't change the shipping. So how do we test for that? And this is where people will often fall into sort of pitfalls, okay? Whenever you test something, you always have a context, you have an event, and you have an expected outcome. So if we write those acceptance criteria into this kind of format, we're gonna have an expected outcome and we're gonna have an actual outcome, okay? When we test that thing and the outcome, the expected outcome matches the actual outcome, we say the test is passed. And when the actual outcome is different, we say it's failed, okay? But that's based on the premise that the context is true and the event is true, okay? If both of those things are true, then our test is valid, right? But what often happens is it's taken for granted that one of these things is not true, right? And so a UAT user will log in and they'll test the event, but not really consider the context correctly. And what will happen there is that they'll be expecting a shipping city not to change, and it doesn't change, and they say pass. But actually, that's not a pass. That's a fail. And what's been experienced there is what's called a false positive. And it goes further than that. So here's just a little joke to sort of demonstrate the problem, right? So there's a guy here, and he's saying he's looking for his caller that he dropped, and the policeman's asking, did you drop it here? He says, no, I dropped it 2 blocks down the street. And he says, well, why are you looking for it here? Well, because the light is better here. And so that's quite funny, but it relates very much to this methodology of testing, right? When things are easy, you just test the happy path. But to become a really effective tester, you need to think through all of these contexts, all of the events, and all of the potential outcomes and routes and test for them. Now, when you do this manually, it's very difficult because there's a lot to test. There's a lot to think through. Whereas if you do this through automation, you can start to build up your regression suites, and you do it once, and if a requirement changes, sure, you need to go back to your regression suite and make that change. But by and large, over time, you have a much more robust way of protecting the quality of your implementations. So a QA engineer walks into a bar, he orders a beer, he orders 0 beers, he orders 9 million beers, he orders a lizard, he orders -1 beers, he orders a blah, blah, blah. And the first real customer walks in and asks where the bathroom is, and everything bursts into flames, right? So that's kind of demonstrating this last scenario here where context has been ignored, the event hasn't been properly tested, but I'm still getting the outcome I expect, and so I'm happy, right? No, you shouldn't be happy. So this is what everyone tests, happy path, right? Everyone tests that. Good QAs will look for the false positives. Really good QAs will have a much wider angle of negative testing false positives. And then the really elite will automate properly and test absolutely everything, okay? You may think to yourself, why would you ever want to test something where both the context and the event are false, right? And most of the time you wouldn't, but you can still get unexpected outcomes from other events which are causing that. And knowing what the source of those is very important to stamping out bugs. So moral of the story, don't just test the happy path. Okay, before we dive into the practical, any questions? So, you guys are very welcome to follow along. I've got links here. Let me first just start out by sending through a link for copying and pasting some text. So I'll come back to this in a second. I'm just looking for the URL. Oh, it's actually in here. I apologize. So I'm going to paste this link into the Zoom chat window. Figure out how to get there. Yeah. Chat. Okay, so I've pasted that link into the Zoom chat window. And as we go through this, I think it's going to be a lot easier for you guys to copy paste some of this text. So that link should take you to this Dropbox folder. Now we're going to be using some of the stuff in this Dropbox folder. You'll see there's a fixtures folder. And in this fixtures folder are some data files, some JSON files. There's a CSV file. And in the root, there's a Google document called presentation text to copy paste. So if you could have that one open as we go through the presentation, and it'll make copy pasting easier. Okay. So step one is we are going to create a dev org. So I invite you all to do this. If you go to developer.salesforce.com/signup, you just put your name in there. You can do this right now with me while I'm doing it. Use whatever email you want there, as long as you've got access to it. And then give yourself some sort of meaningful username. I'm just going to put the date in here because I've used that. Okay, and then once you sign up, you should get an email. And if you open that email, click verify account. It'll ask you to set a password. So just set it to something that you're not going to forget. Set your reminder. And you should log in to your DevOrg. Okay. Once you're logged into your DevOrg, in the quick find, if you just type DevHub, click the DevHub link, and then enable all of these flags. Don't really need Einstein, but why not? So make sure DevHub is enabled and make sure unlock packages is enabled, okay? So now we've got our DevOrg. We've changed our password, we've gone to DevHub, and we've enabled those flags. So step 6 is now you're going to install DX on your machine. So if you've already installed DX, that's fine, you don't need to do it again. If you haven't yet installed it, I'll share the link with you now. And this has got instructions for how to do it, depending on if you're on Windows or Mac or Linux. There's different ways of doing it. So download that file, install it. I'll just give you a minute to do that, and then we'll move on. So I do need to be conscious of time. Unfortunately, I can't wait until everyone has done this. So I'm going to be moving on. If you need to come back to the slides, I can share those with you. Put that link in the Zoom as well. Yeah, so if you feel I'm going too fast and you want to rewind through the slides, I'll just put the link in there. Okay, so once you've installed DX, the first thing you want to do is type SFDX update. Now, if you've just installed it, you won't need to do this, but for those of you who already previously had it installed, if you could please run this command now so that we're all working off the same version, because if you're getting errors, it's related to your version, it's not going to help get us through today. So we'll let that run. And then after that's finished, if you could just go ahead and create a working folder anywhere on your computer. You can call it whatever you want. So in my example, I've just called it Architect Forum Demos. But we're going to just use that and not conflate that with any other project folders that you've got on your machine doing other stuff, right? Just a nice, clean, empty folder. So I'll give you a minute to do that. Okay. And now what we're going to do is we're going to create a Salesforce DX project. Okay, so basically to do anything in DX, you need to have a project. And the command for that is the following. SFDX force project create, and then -n, you're going to give it a name. And in this example, I've called it test automation. I'm not going to use that because I've already used that. So I'm going to call it something else. May 29th. And you should get some sort of output that looks like this, okay? And it'll show you the files that it's created. I'm not going to go through them all now, but basically that's your Scratch definition file where you are going to specify what features you want your Scratch org to have. You have some scripts folders, we'll look at those later, and then some other sort of hidden files that facilitate the application. Okay, so the next step now is we need to link this project to a dev hub. Okay, so that dev org that you created previously and you enabled dev hub on, we now need to link our Salesforce instance, our Salesforce project to that dev hub. And the way you do that is by typing SFDX force auth web login, and then you're going to use the -d flag, which tells you that this is the default dev hub, and then you want to give that an alias. So I've already used the dev hub alias for another org, so I'm going to call mine dev hub May 29th. Okay? And if this is the first time you're doing this, then you can just call it whatever you want. Okay. And now what I'm going to do is log in with the username and password that you created previously for your dev org, and you want to allow access, right? So we're creating a auth token handshake here. And if you go back in your terminal, you should see a message that says successfully authorized your dev org username with org ID. No, you may now close the browser. Okay. So you can go back and you can now close that browser window. We don't need to be in our dev org anymore. Okay, back to our presentation. So now what we're going to do is we're going to create a Scratch org. Okay, so we've installed DX, we've linked DX to our dev hub, and now we're going to create a Scratch org. And you have to link your DX project to a dev hub before you can create a Scratch org, because all Scratch orgs are effectively owned, if you will, by a particular dev hub. And this helps developers work on multiple clients at the same time. So if you go in now to that project folder that you created, mine was May 29th, okay, and if you just list out the files, you'll see what that project creation has created. What we want to do now is copy this command here, right? So we want to create a Scratch org by typing SFDX force org create -f, and then what you're going to just do here is use the default project Scratch definition JSON file. I'm not going to open that file now, but what's in there are just some settings basically for your Scratch org. So if you wanted to activate person accounts, you flag that in your JSON. If you wanted live chat, you would flag that as a feature. So your org is going to be provisioned with these certain Salesforce features, but we're just going to use the default stuff. Okay? The -s flag means that this is our default Scratch org, because you could be working with lots of Scratch orgs. So this is going to be our default. And -a is an alias, right? So I'm just going to call this default May 29. You can call it playground or whatever you want. And that should take a couple of minutes. So in terms of what's going on in the background now, Salesforce isn't, as far as I'm aware, it's not actually provisioning a Scratch org. It's got a whole bunch that are waiting to be assigned to users. So it's just picking one and assigning that vanilla Scratch org to you. Okay, so it's done that now. It's giving you authorization to log in. You've got a username to log into that Scratch org. And we've also defaulted it. So we've got a default dev hub linked to our Salesforce DX instance, and we've got a default Scratch org, okay? If you now type force org list, you'll get a list which looks something like this, telling you or showing you all of the production orgs and sandboxes that you've got linked to this DX project, and which of those have dev hub installed and which of them is the default dev hub, and a list of Scratch orgs, and which is the default. So you'll have a flag here for the default Scratch org and a flag here for the default dev hub. So where are we right now, right? If we visualize this pictorially, okay, you've got your machine here. You've installed DX. You've got some project folders, and in those project folders, we're going to build some metadata. We're going to put some data. We have authorized that dev org that you created previously with DX, okay? So your dev hub is linked to your DX project. And you've also created a new Scratch org, right? And that dev hub owns that Scratch org, okay? So this is more for sort of administration. This is where we're going to be doing our actual development and testing. And we're going to use DX to move metadata between our machine and the Scratch org, okay? Maybe in a follow-up webinar, we can tie this into the whole continuous integration game. But the idea here is that your metadata now is going to be a source of truth in your repo, and that needs to be managed on a server, right? So if you're using GitHub or Bitbucket, at the end of your day, you know, if you're a developer, you've developed your stuff, you're happy from a unit test perspective, you'll then commit that to a feature branch in your Git repo. And as far as packaging and automation around deployments and continuous integration is concerned, your Jenkins or Bamboo server will be running commands on that Git repo, and it will have its own instance of DX configured within it. So effectively, it's automating what you're doing, but from a different server. We won't go into that today. Okay, so if we just look back at our force org list. Yeah, so this command can take very long. I've noticed in the past couple of days that it's been very, very slow. I don't know why that is, but after about 5 minutes, you'll get a printout of all of the orgs listed to your project. Okay. Okay. So what we're going to do now is open up that Scratch org that we provisioned. Okay, and you can do that by typing SFDX force org open. Okay. If you've got lots of Scratch orgs that you're working with, you will actually specify which Scratch org you want by using the U parameter. And you can either use the actual username here, or you can use the alias of your Scratch org. So Scratch org 5, whatever it is, and then it'll open that one. If you don't use the parameter here, it'll just open the default one. Okay. Okay. I'm not going to wait for this to finish. It's going to slow us down too much. So let's just go into the Scratch org that we provisioned. And boom, there it is. So with that single command, because I've got that trust relationship established already between DX and Salesforce, I don't have to log in. I've got that session running already, and I'm in. Okay. And what we're going to do now is we're going to build a quick feature, right? So if you go to Process Builder, we're going to create a new process, okay, very quickly. It's going to do something very simple, okay? And we're going to call it match shipping address to billing address. Okay? You can call it whatever you want, it doesn't really matter, but that's what it's going to do. And that process is going to start when a record changes. So if you save that, come into your process builder, add objects. If you just choose the account object here, when a record is created or edited, and then in your criteria, give that a name. Again, you can call it anything. Select formula evaluates to true. And then if you go to this document, there's actually a sample that you can just copy paste. In step 16, so if you just copy that. So this process builder is going to fire on creation or updates of account records, and only when the record is new or it's being updated and the billing city is changing, but only when the shipping city is blank. Okay, that's what we're building here. We're going to test that logic later. Okay. And then what do I want to do? I want to update a record, update shipping city. The record we're going to update is the actual account record that started the process. And we're going to change the shipping city field reference billing city. Okay, so shipping city becomes billing city when this criteria evaluates to true. Okay, save that, activate it. And so now we've got a very basic piece of business logic sitting in our Scratch-all. Now, obviously, you wouldn't be doing this as a QA. Your developer would have done it, and they would have pushed the metadata into the Scratch-all for you. But just for the purposes of an example, okay, so I'm going to go account test 001, and I'm going to come down here and type in billing city, and I'm going to click save. And now my happy path expected outcome is that shipping city updates to London as well. So I click save, I go to details, and happy days, shipping city has changed. Okay. Now I'm going to test my second acceptance criteria, which is that when I edit, the shipping city should not change. And it hasn't, right? So my process builder, from a manual testing perspective, seems to be working well. Okay. Okay, so we've done all of this. So now let's do it in bulk. Okay, so we're going to generate now some test data, and there's lots of services that you can use to do this. The one I'd recommend for this example is Mockaroo. So if you go to mockaroo.com and just get rid of all of these and type in the following. So ID, just keep that blank. I'll come to why we need an ID field in a minute. Okay. Billing city, type city here. And then account name is just name, and you can type company here, company name. And that's going to generate for us a CSV file of 1,000 rows of randomized data with some random cities in there and some company cities as well. Okay. I'm just going to do one other thing quickly, which is because this is a free tool, you tend to get repeating account names here. And I want to make sure that all of my account names are unique so that if I need to find one and differentiate it between another one, I can do that. And so this command here will just print the date in a Unix format to 4 levels of precision at the end of it. So it will always be unique. Every row will be unique. Okay. I don't think the line ending matters. I'm on Windows, so I'm going to choose Unix, but it shouldn't matter. And I'm going to download that and open that up. And I can see here, that's great. I've got 1,000 rows of data with some billing cities. And the benefit of using a tool like this is it's going to put in all sorts of weird stuff, all weird characters, you know, Taiwanese characters, etc. Exactly the kind of stuff you want to test as a QA. And then we've got the account name, and they're all unique. Okay. So great, I've got my file. And the reason I've asked you to put an ID column there is because we're going to use the bulk API in this instance. So if you remember earlier, I said that BX there's 2 ways of getting data from your repo into a Scratch-all. You can use the bulk API, or you can use the REST API with JSON fixtures. Okay, I'm going to do both, but I'm going to start off using the bulk API. And the bulk API with Salesforce DX, you use an upsert command for that. And an upsert command always requires an ID column, whether or not you have an ID. Okay, so that's why I've put an ID column in here. All of these are going to be null because they're new records, but that's why it's required. Okay. So now what you want to do is copy that mock data file into the data subdirectory within your project folder. Okay, so just to visualize that, if I open up Finder, sorry. So May 29, that's the folder I created. So you'll see there should be in here a data folder. I don't know why I don't have a data folder. So just create one if you don't have one. Okay, so create a data folder, and then you can drag your mock data file in there, right? So I've done this lots of times. I think that was the one I just created now. I'm just going to rename that. Okay, so we've looked at it already. So I've got that mock data file in my data subdirectory. And now what I want to do is I want to get that data into Salesforce, right? And there could be 10,000 rows, there could be 100,000 rows. Because it's using the bulk API, it doesn't really matter. Well, there is a theoretical upper limit, I think it's 1 million rows. To kick off or to create a bulk data API job, we're going to type this command. Okay. So first of all, I want to navigate to my data folder, and now I want to type SFDX force data bulk upsert, specify the object like you always do with bulk API, and then specify the file that you want to upload. And then you also need to specify the column that the upsert would use to identify which field. This is null, but you still need to do it. It's a requirement for the command. And the neat thing with DX is once that job has been created, it'll actually give you a command that you can run to check the status of that job. So if you copy paste that output here, it'll tell you that the job is still in progress. This is quite weird. I would have expected it to finish by now. And now it's completed. Okay. So if I go back into my DX.org, create a new list view, all accounts, filter by all accounts. I should now see all of those accounts that I've created. So that's pretty cool. You know, as a tester, if you're doing any high volume data testing, you've got a really easy way of taking a CSV file, putting that into your repo, having it live and be a sort of, for test purposes, a source of truth in your repo, and you can make different versions of it. You can put those different versions of that data into different subfolders to match different test cases that you're running, right? And you can upload that data, run some tests, tear it down, upload different scenario data, test that, tear it down, etc. We'll get onto that next. So I want to test something, right? I inserted name and billing city, but I expect shipping city to be updated, right? So now what I'm going to do is the reverse. I'm going to retrieve those records that I've actually just uploaded. And to do that, I'm going to use the SQL query, okay? So force data SQL query -q, and now I'm just going to type select ID, billing city, shipping city from account. And you can put some additional filter criteria on here. So as a QA, you should be familiar with this, you know, records created today, by user equals me, you know, that kind of thing, just to make sure you're querying data that fits your test case. Okay, and result format CSV. I believe the default format is JSON, so you need to tell DX to output the results as a CSV, and then you need to pipe those into a document, okay? I'm not sure in Windows, so this isn't part of the DX command line. This is a Unix command line to take output from standard output and put it into a file. I think it might be the same in Windows, and I'm not sure. So I've done a query now, and if I open that results file, open the window, I can see that all of my data has been updated the way I would expect it to. And as a QA, you know, pass, fail, whatever. You can write some logic here to tell you what was right and what was wrong. So that first record there was obviously the one I created initially, but everything else seems to have done what we expected. Okay. Right, so that's single object bulk API way of using DX to get data in and out of a Scratch org to help testing. So let's talk now about sort of building an automation suite. Okay, so building an automation suite with DX, just like making a meal, requires some ingredients and a recipe, right? So the ingredients for that are, you're going to need test data fixtures, and those test data fixtures are going to align to what it is that you're testing and all the different scenarios that you're testing, right? So a good way to sort of organize your test data fixtures are in subfolders. So within your repo, organize that your subfolders, align them to business processes or user stories or whatever it makes sense for your project, and make sure that you keep that data up to date, right? And always aligned to what you're testing. You then need some scripts to delete data from the org, because remember, with unit tests, your data doesn't persist. It gets destroyed at the end of your execution cycle. So if you want to test and then retest and retest and retest, you're going to need scripts to delete the data that you've just uploaded and restart from scratch every time. Okay, so modern testing tools do have this feature already. DX doesn't, as far as I'm aware. There are bulk API commands to mass delete records, but it requires you uploading a file of IDs, right? So to simplify that, I'm going to give you a teardown script. And then you need scripts to create reusable nested data in an org, right? So we looked at the bulk API method of single object data uploads. What we're going to look at now is more complex structures where you've got an account and child records, right? Now, if you use bulk API to upload that data like that, it gets quite hairy and complicated because you need to keep multiple tabs, and the IDs, the foreign keys, and the primary keys of those tabs need to all tally up, and that's hell to manage. It's much easier to create your test data in a test org, export that using the data tree export function in DX, which I'll show you next, and keep that living in your repository as JSON file, so that every time you spin up a new Scratch org and you've got a new test case, you just type one command and bam, you're at starting position 0 again. So once you've got that in your org, you can start now to think about building your regression test scripts. And you don't necessarily have to use Apex to do that. You may prefer using another tool. If you've got the luxury of Provar, which is very well suited to Salesforce, then you could embed that into your scripting. But for this example here, I'm just going to show you a very simple anonymous Apex script, which is going to just test the feature that we've built. Okay. And then finally, when we get to actual continuous integration builds and baking the automation process into that, you need some automation scripts. And typically, automation scripts are like Bash. They're the native sort of scripts that you would expect to be able to run on a Windows machine or a Unix machine, right? So whatever the server is that's running Bamboo or Jenkins or whatever, you know, you need something that can run DX command files, that can pull data out of files out of folders within your repository, that can pass that data into DX. And so we're not going to look at that today, but that's the last sort of thing that you would need to automate your regression process into your pipelines. Okay, so so the first thing in building out a regression pack is to come up with a teardown script. It's called the teardown script, right? So I've got an example of one here, and all this is going to do is it's going to query accounts matching whatever criteria you want. Okay, so for this script, I haven't given it any criteria. So this script is going to wipe out every single account in an org. So caution, be careful. But if you're testing something very specific and you want to reload that data and test it again, but only that data, then you need to filter out the other data that you don't want to delete, right? So you want to, if you're running a teardown script and you want to parameterize this then that filter criteria is really, really important. Okay. So if you hop into this copy paste text file, you can just copy this, step 24, into a notepad. So if you navigate back to your scripts folder, so remember in your root folder of your project, there should be a scripts folder which DX has created for you. If you go into the Apex folder and just create a new file called teardown.apex, and now open up a text editor. So you can use open command, or I use Sublime. So open that file up in Sublime and then just paste that text, close it back down. And now we've got in our repository, in our local file system, a teardown. So if we wanted to use DX to execute that script, we would type the following command. It says SFDX force apex execute, and then specify the file. And I believe that's it. Okay, and then you'll get some output. So that's deleted 1001 accounts, and it would have also deleted all the child records under those accounts, all the cases and contacts, etc. If I go to all accounts, it should all be gone. My contacts should also be gone. Let's just make absolutely triple sure. Yeah, so that's successfully deleted everything, and we can now reload. Okay, so now we're going to look at the other way of getting data into DX using into a scratch org using DX. Okay, I'm not going to do the process of creating the data because it's going to take too long, right? But as a QA, what you would do is go through the process of creating accounts, or if you can get a sample of accounts from your pre-prod org, do that first. Go into your pre-prod org, create those accounts, or go into any org, create those accounts, create those contacts, opportunities, whatever data you need to test your features and your use cases, okay? Create the records in the right way that you want them, and then you can export that data using the DX data tree export command, okay? And what that's going to do is allow you to generate a SQL statement which can be nested. Okay, so this is a nested SQL statement which is querying the account object, but it's also querying any child contacts, and it's also querying any child cases. And if you run that query using the tree export command with a plan flag, what you get at the end of that is something that looks like this. Okay, you'll get a JSON file containing every account. You'll get a cases file containing every case, and you'll get a contacts file containing every contact. And they all tied together using foreign and primary key matching, which is based on how DX has designed it, right? So it's not using the Salesforce IDs. It's just putting its own text sort of reference anchors in there. And those get created by DX on the fly, right? So if I look at this JSON object, I can see this is a contact record, and its parent is account ref3, right? And so if I look in my accounts file, I expect to see an account ref3 in here somewhere. Right? So that's account ref3, and so that contact record will go underneath this account record, right? And then finally, you've got a plan file which ties everything together. So your plan file says, in this plan, I've got accounts, I've got cases, and I've got contacts. Here's the accounts file, here's the cases file, and here's the contacts file, and you've got some other attributes as well that that tell you how to import the data. Okay, so I've got some of those sample files. I've downloaded them already. I'm going to move those to my data folder. And you guys can do the same. You can download from the Dropbox. They're exactly the same files. And now if I look in my data folder, I've got my fixtures. Okay, so now I want to import that data. So to import the data, we just use the reverse of this command, which is tree import, okay? So I've already torn down my data. There's no data in my org. Now what I'm now going to do is I'm going to import that data. Okay, so that command is SFDX force data tree import. And we're not importing discrete files. We're importing the whole plan. And so all we need to do is specify that plan file, and the plan will tell DX what other files it needs to, you know, what the hierarchy is, what the childs are, etc. You don't have to do any of that thinking, which you would have to do if you were using bulk API. Okay. And then that's my results. So if I hop back into Salesforce, I can see some test data, and look at that, there's a case on there. And this one's got another case. And this one has got a contact, but no cases. Okay, so that's pretty cool. From a QA perspective, can really speed up the process of moving data in and out of orgs. Okay. Okay, moving on. So the last bit here is now moving into sort of the real business logic automation side of regression testing. Okay. As I said before, you don't necessarily have to use Apex for this. You can use other tools. Provar is a really good one. So Provar is a tool that can be run either from your machine or off a server to run scripts that test web applications. And the really great thing about Provar is that it can either be configured to run in a classic DOM operating model, so where it's looking for element IDs in sort of older way of building web pages, or it's got a sort of lightning mode. I don't know how it works, whether it uses XPath or something else, but it can be configured to and specialized for actually testing lightning pages. So it doesn't look at the element ID, it looks at something else, the object naming, to get the actual elements where it needs to put data and click buttons, etc. So if you want to do automated testing from a UI, you know, clicking on the screen perspective, Provar is a really good tool. But if you just want to test simple business logic, you know, create some records, change some data, observe the expected outcome and compare that to the actual outcome, then I find Apex is actually great for that, right? And just to remember, what we're doing is we're building functional test scripts. We're not building unit tests. That's the developer. The developer writes their unit tests. They package that with their code. This is a different ballgame, right? In a regression pack, what I would expect to see in an automated regression pack is a regression script that creates a lead, that adds some data to that lead, that changes the status, that checks things are happening as you change the status. Maybe you are automating the creation of a task when you change the lead status. And an Apex regression script is fantastic at doing that. So you would start by loading in 1 million accounts through DX using your JSON data tree import, and 1 million cases and 1 million contact, whatever. You get a nice big representative volume sample of data, which is approximating production. And then you run your regression scripts, and your regression scripts are process-based or feature-based, and they will run through the different scenarios using these BDD criteria, okay? So I've just given one example here related to our earlier feature. So given accounts where the shipping city is null, very simple SQL query to get that data. When the billing city is changed to a non-null value, so loop through all of those account records and update the billing city to something different to what it already is, then the shipping city should match the billing city, right? So then you can select that data again, loop through it again, and check and test that the billing city matches the shipping city in all cases. Okay. This is very crude, the script, but it will do the job for what we want to test. So I've got a sample here of that script, and it's going through 2 acceptance criteria. It's going through where shipping city is null and where shipping city is not null, right? And it's doing some updates and it's testing the results. So if you wanted to copy that into, again, your scripts folder, you know, and as a QA, you can start to take some control over this, right? You can start to have subfolders of your different use cases, and in those subfolders can live scripts and data fixtures, and they can be married up and coexist together. And you can execute manually yourself by running script commands when you're doing some new testing, and when you're happy with that, you can put those regression scripts into your continuous integration build pipelines. So let's do an example here. So go into my Apex. Let's create a new one called scenarios. Paste that in. And then just like we ran the teardown script earlier, we're going to run the same command. So force Apex execute file scenarios Apex. Okay. And that's tested, and if it would throw any errors, you'd see them here in the output. I won't go into this now, but you can also configure the output of a regression test to feed into something like Maven's Mate or these other sort of Java applications, which can pipe the results into nice reports that Bamboo or Jenkins uses, right? So if you think of a Bamboo setup, when you run a build, part of that build is going to be your regression scripts, and it's pretty useless having the results output into a terminal like this. You want to see them visually, and there are ways that you can get the output of the test results here to feed into those files that the Java application uses to present and to tell Bamboo whether the build has been successful or not. So this is all run. So that's okay. And all of my acceptance criteria 1 have been successful, or my acceptance criteria 2 has been successful. Okay. But I mean, in this particular example, there aren't any records where the shipping city is null. But as a QA, you could go in, you know, do a bulk update, maybe set 50 of them to null, and then run the script again just to make sure that, sorry, do 2 things. Set this shipping city to null for like 50 records out of 1,000. Update the billing city across all of them, and then run the script, and the script will tell you whether or not those scenarios are playing out as you would expect them according to the acceptance criteria defined in the user story. Cool. So that is pretty much it for the practical. Just to wrap up, quick conclusion. So what did we learn today? So we learned what Salesforce DX is, and we learned what its main use cases are from a developer perspective and from a tester perspective. We learned what a scratch org is and how it differs from a sandbox. We learned the differences between functional tests and unit tests. We looked at that mind map of Salesforce DX features that can be used to facilitate testing, and we looked at some of the commands to help testers. And then we looked at some of the theory around why things often fail, even after testing. We learned about negative test cases, false positives, and looked at some of those common pitfalls. We then zoomed into sort of scenario testing, and I was explaining the different contexts in which testers should be testing, making sure you're always looking at scenario and event, not just event. And then we came onto the practical. So we created a dev org, we enabled that dev hub on our dev org, we linked that to DX project. we created the project, we provisioned a new scratch org, we opened the scratch org with DX, we added a feature, we created some data manually to test that feature. We then created data in bulk to test the same feature using DX. We then extracted some nested data in bulk using the data tree export function. And remember, you can do this in production, right? So the data tree export function, I believe, works in sandboxes and production as well. So if you get the authority from your client to allow you to extract data from production, you may want to scrub it, remove emails for GDPR reasons, that kind of thing. But if you can get that authority, that's great. You know, especially in these environments where customers don't have pre-prod, you know, representative data samples. You can do an extract and test some of that. We imported that data back into Salesforce using the tree import function. And then I started walking you through what you would do to build a regression pack, which later can be built into a continuous integration build, right? So that was data fixtures, whether there's a JSON or CSVs. We looked at some scripts to automate the loading of that. We built a script to tear down that data. And then we looked at a little sample Apex file, which can be used to test a regression. And you know, over time, as a project evolves, those regression scripts will grow in complexity. But from a QA end-to-end testing perspective, are pretty critical to ensure quality. So that's it. I think we've come in under time, which is great. So we can use the rest of the time to go through any questions anyone has. I'm conscious I did speed through a lot of it. So if there's anything in particular anyone wants to ask, now's the opportunity.
I think one thing I'd like to say, Mark, that session was really very good. Very good. Good introduction to DX. Let us see some of the commands, how quick it is to get orgs provisioned, scratch org set up, data in and out. So yeah, I was trying to follow along and got things done. So thank you very much, firstly.
Very welcome, thank you. Yeah, so the session is recorded. I'm very surprised at the time. I practiced this beforehand and it took me 2 hours. And so I told myself I need to go faster through certain areas, but I think I've gone too fast through some areas. So we can go back. We've got a little bit more time. We can go back and explore those. We've got 10 more minutes. I did want to say one other thing. So we talked about scenario testing earlier in the presentation, right? And you know, very often when it comes to context, one of the important contexts is which user you're actually testing something as, right? Now, unit tests are very good at this in Apex. There's a command called system.runAs. And system.runAs basically allows you to run a series of Apex tests as a particular user. Right? Or within a test, you can run some business logic as a particular user. Now, when you run anonymous Apex, there is a difference between how an Apex test as a unit test executes and how anonymous Apex executes, right? Test execution, I believe, is done in system mode, whereas an Apex anonymous script is done in user mode, right? So user mode takes into consideration your profiles, your permission sets, all that kind of stuff. And unless you have built classes that are specifically designed to look at sharing rules, so you can use the with sharing modifier, without sharing modifier. But if you don't use those modifier, Apex classes typically don't run sharing rules. And if you run an anonymous Apex, a unit test, it'll be run in system mode and it'll ignore sharing rules, right? And so there is a way in unit tests to run as particular users that you don't have that same luxury with an anonymous Apex script. So if you wanted to use Apex to do functional regression scripting, you can't use that run as. But what you can do is create more users on your scratch org using a DX command, or using a very simple DX command. And even this is something that can be automated in a continuous integration build, right? So if you look at the yeah, this is just an article explaining the difference between system mode and user mode in Salesforce and what the different contexts are. So when a trigger runs, it runs in system mode, validation rules run in system mode, flows run in user mode, and so on. So if you're using DX, I thought I had it open here, but if you go to the DX help documentation for the user commands, you can actually use DX to create users with specific profiles, with specific roles. You can drill down to exactly where in the role hierarchy they sit for your test case scenario. You can assign a different profile, a different permission set, whatever the use case is, and then you can run those regression scripts as that user. So it's a bit of a different way. In a unit test, it's very easy. You just query a user in the database that matches a particular profile, role, or whatever, and then run your code as that. Whereas in an anonymous Apex script, you have to run the script as the user, right? But DX makes it easy to create users on the fly. I've never done it myself. I do question actually how they manage the licenses. So, you know, if you only get 2 licenses, I don't know how many DX users that allows you to create. But the benefit is that you can script all of that, right? So you can have a Bamboo pipeline that builds, and that Bamboo pipeline is going to run a whole bunch of regression scripts as a sales user, a different bunch of regression scripts as a marketing user, a different bunch of regression scripts as a system admin, et cetera, et cetera, et cetera. So that's very important, and yeah, worthwhile considering. Cool. Any more for any more? Dimitri, what do you think? Sleeping. Do we have any testers on the call?
Yes, we do.
Uh-huh.
Yeah, I find it really, really useful. I was about to thank you on chat, but yeah, the presentation was really great, and I think we should definitely share it among the testers in VRP.
Yeah, I mean, I'd say from my own personal experience, you know, I've worked in some big organizations where it's like they want to use Provar and they want to use Selenium, and it's like politics and 6 months of trying to get organized with licenses and stuff. And it's like all of the 6 months you don't have automation. And the great thing with DX is like, you've bought the Salesforce license, you have DX, right? You just need the skills. Yeah, and we have those skills. We have automation testers. And so if we're working on projects where a customer doesn't have like Provar licenses or Selenium licenses, well, I don't know if Selenium is
for Selenium, you don't have to have license here, but
yeah, it's free, it's open source, yeah. But
you have to have skills.
You have to have skills, yeah. But you nonetheless, if you're building a Bamboo orchestration suite on the infrastructure of your client, there may be political issues around getting Selenium installed on there, right? And it's typically much easier to just start using DX than getting external applications that are foreign to Salesforce embedded within those continuous integration setups. At least that's been my experience.
Yeah, you know, I think the problem with SFDX and QAs is the letter D in the abbreviation, which stands for developer, right?
Yeah.
So I think you managed to sort of bridge the gap, at least a bit. And yeah, I think yeah, it should be shared among all the QAs in the company.
Yeah. So this orange bit here is for sure this is the developer world for sure. But this is the tester world. This is QA. And I'm not saying developers won't use these functions to test their stuff as well, but it's beneficial certainly to automation engineers. Cool. Okay, should we end it there? 2 minutes left.
Okay, Mark, can I ask a last question?
Of course. Yeah.
Yeah, thank you for your session. It was really great. And I just have one question. Well, did you know the projects in the real time with the real clients who use this approach, kind of they create the test scenarios, because it will take time. And do we have some kind of the cases that we explained our clients that we have to do this kind of the right scenarios to test more precisely?
Do you mean like how user stories and acceptance criteria are written?
No. I mean, did you apply this approach, like test regression, in the real project?
Oh, I see. Yes. So I did this at Jaguar Land Rover, not using DX, but we used the Atlassian stack for continuous integration there, and we wrote a number of regression scripts in Apex, which lived in the Git repo, right? And they were run by Bamboo, in addition to the unit tests that were run by Salesforce. So, you know, this was version 1 packaging I'm talking about, right? So we used Ant and the generation 1 packaging to build the packages. And then we would deploy those to a test server, run all the unit tests, and then run functional regression scripts as well. And those were written in Apex, and they did tend to follow this model. And the QAs were responsible for keeping those regression suites up to date. So as you know, we would have a sprint meetings every week or whatever, and whatever new features that we were deploying to the sprint, the developers were responsible for making sure the unit tests passed, and the QAs were responsible for making sure that their regression scripts were kept up to date with the new features.
Okay, so clients note about that QA start kind of the new testing approach, like test regression, right?
Yeah.
Okay.
Yeah.
Thank you.
Yeah. So I mean, in that example, so the way Salesforce is administered at Jaguar Land Rover is by the business, right? So the IT teams actually, we were lucky they didn't get involved. So there was a whole team of developers and testers and architects and analysts that worked on Salesforce. And so we had everything within our control. It's not like we had to go to the Jaguar Land Rover quality assurance team and get them to change their behaviors and practices. We were lucky, right? We could hire our own QAs as contractors and develop our own practices and cultures ourselves. I'm very conscious that that's not always the reality and the possibility of every client that you go to, especially some bigger clients, certainly banks.